All right, now we're going to do inference for a difference of means. So when we do this, we're using a t-distribution. We're computing the standard error, but it doesn't change between the confidence interval and the hypothesis test. And we could either use R as a big calculator, or we can use some functions. So I'm interested in seeing whether the mean number of years of school completed is different between people born in the US and those born outside the US. So we're going to start by computing our point estimate. Like before, I would encourage you to try and do this on your own before you go on in the video. Okay, so I'm going to do the mean, and I'm interested in the mean of, what was that variable called? Highest year of school completed. Highest year of school completed. Does it have an of in there? Yes. And then I'm going to break it down by born in US. I think that's what this variable is called. Born underscore in underscore US. Yep. And then I'm going to do comma data equals GSS and control enter. Okay. And again, I could do the subtraction myself. 12.85 minus 13.97. And it's a difference of 1.12. So our observed difference is negative 1.12, which means that people born outside the US are getting 1.12 fewer years of school than people born in the US. But again, that's just our point estimate from this sample, and we want to see, is that statistically significant? So let's start with a confidence interval. We're going to do a confidence interval for the difference of means. And so we want to do a t-test. And again, this is going to be similar to before, so I'd encourage you to stop and see if you can figure out how to lay out this t-test. Okay, I'm going to do it. So it's going to be really similar to our mean code. We're going to do the highest year of school completed, tilde born in US, comma data equals GSS. And we can try just control enter and see what it comes up with for us. It makes a 95% confidence interval by default, so I think we're good to go. So then the question is, how can we interpret this interval? And we could say, I am 95% confident that the true mean number of years of school completed by someone born outside the US is between 1.80, let's say, years less and 0.45 years less than someone born in the US. So because that whole interval is negative, we're sure that this person is born between 1.8 years less and 0.45 years less than someone born in the US. All right, and now we're going to do a hypothesis test. So we want to know if those means are significantly different from one another. And let's write out the hypotheses using LaTeX. So I'm going to put the dollar signs at the top and bottom. H underscore 0 is going to be slash mu1 equal to slash mu2. And then H underscore A is slash mu1 slash NEQ slash mu2. And again, I could subtract mu1 minus mu2 is equal to 0, and mu1 minus mu2 is slash NEQ 0, so that I'd have my null values there, just to remember. And then in order to perform that test, we're just going to add some more parameters. So I'm going to just go up and copy this t.test code. And then let's put our cursor inside the parentheses, put a comma, and then hit tab. And now we want to make sure that we have our alternative, which is going to be 2.sided. And then I think we want to have our mu equal to 0 to tell it what our null value is. So let's control enter here. And again, it's given me my p-value. That's the most important thing. And so our p-value is 0.001162. So at both the 5% level and the 10% level, we reject our null hypothesis because 0.001 is less than 0.05 and 0.1. So those were our cutoffs. We have evidence to suggest that there is a difference in mean number of years of school completed between people born inside and outside the US. So again, this goes with our conclusion from our confidence interval, which was all negative. That means that there is a statistically significant difference. All right, and then the last thing in the lab is inference for paired data. So we want to think about paired data. There's lots of ways to do this in R, but the best way is to take your paired data, find the differences, and then do inference on that variable of the differences. So this data set is assuming heterosexual marriage, and someone would have a mother and a father. That's the way the data is set up and the questions are asked. So the mother and father are kind of naturally paired. Everyone has one of each. And so if we wanted to see if the mean level of education was different between mothers and fathers, we could make a variable of the differences and do inference on that. So here's what I'm going to do. I'm going to take my GSS data and I'm going to overwrite it with a transformed version where I'm going to say GSS and then diff is equal to the highest year of school completed of the father minus the highest year of school completed by the mother. And if I control enter and go back to my GSS data, now I should have a new variable at the very far right-hand side of my data, which is difference. So this first person, their father completed 8 more years of school than their mother, 4 more years of school. Now here the mom completed 4 more years. We've got some NAs in here, but because we've got our NA action, I think that's just going to get taken care of. And then we're going to do inference for this diff variable. So we're going to do inference just like we would for a single mean. We're going to start by finding the point estimate. So I'd encourage you to try and do that on your own before you move on. And now I'm going to do it. So we're going to do a mean, and we're going to do a tilde and diff, because we only have one variable now. And then data is equal to GSS. And if I control enter, there's my mean. So our point estimate was negative 0.057, which means that the average number of years that a mother went to school is 0.057 less than the father's. But again, just a point estimate, and we want to do some inference. So we can do inference just the way that we did in the single sample lab, that was lab 7. And I got some code from the last lab, and the goal is for you to transform it to work on this data for this new lab. So try that out and see if you can figure it out. All right, so what we need to do is substitute this variable and change that to diff. My data is still GSS. My alternative hypothesis I'm going to leave as two-sided. And then I need to figure out what my null value is for mu. And in this case, it's going to be 0. So I can control enter. I've got my 95% confidence interval, and I've also got my p-value. So if I was going to think about a hypothesis test, because our p-value is 0.5748, which is large, we fail to reject the null hypothesis. So we do not have evidence to suggest that the mean number of years of school completed is different for mothers and fathers in the paired situation. So it might have been different if we'd looked at the overall mean for mothers and the overall mean for fathers and tried to find the difference. But now we're saying, like, on average for a couple, a heterosexual couple, is there a difference? And no, there's not. So that's the conclusion for the paired situation.